Okay, here we go. So we're going to be looking today at extrema. Extreme. It's probably stuff you could probably figure out looking at some of these words, figure out what they are and what they mean. But we're going to talk them through anyway. Because what extrema are just highs and low points. So like tops and bottoms, peaks and valleys. That's an M, I sort that to be the word in. High and low points. Peaks and valleys, mountains and valleys. Maximums and minimums are the technical names of them. But whatever works for your brain for it's those little bumps, and dips. A maximum on the graph is the very highest point. The maximum is the very highest. It's the tippy top, peak of the mountain. The minimum is going to be the very lowest point. And those are well and good and useful information, but sometimes it doesn't give us a really good image of our graph. What if it's got wiggle, squiggle, wiggle, squiggle? So we have something called a relative maximum and a relative minimum. And what those are, it just means in its little neighborhood, it's the highest. So in the nearby area. So a relative maximum is a point. I'm going to get a different color. There we go. Let's go dark green. So a point on a graph where no nearby points have a higher y value. Baby mountain. So it could be that we have a graph that goes big peak and then little peak. The big peak would be the maximum, and a little peak would be a relative maximum. We'll look at it and what it looks like. There we go. So if we have a So this would be our maximum up here, way up here. And this would be a relative maximum because there's no other points nearby that have a higher y value. By that same flavor, same kind of vibe for the relative minimum. So it's a point on a graph where no nearby points have a lower y value. So again, we'd have our true minimum here, way down here at the bottom, and then it would have a relative minimum here. It's a little valley. So we're talking about our peaks and our valleys, high points, low points, minimums, maximums. And we are going to look at 3 pictures to do so. Naturally. I have them for you. Okay, so these 3, and then we're going to be looking on our weird stuff. Okay, so really short time. I just want to make it so you guys have to do as little guesstimating in your notes as possible. The tool I use for the part that's the puppy. Alright, so we're going to look at the f of x and g of x together, and then we'll look at the wiggle squiggle mountain graph. Boop. We got f of x and g of x. This is one of those times when we are going to have our y's listed in that function notation. We're going to get used to it. The little boxes with the scissors and glue sticks. That was new this year. It's working quite well. I love it. Yay. I love when my ideas actually work. Sometimes they're just chaos, but this one works. All right, so when it says find the extrema, it means we're looking for those highest, lowest, those peaks and valleys. We are not always going to have all of the kinds of extrema. So let's look at f of x, our U-shaped guy. What kind of point do we have here? Are we going to have a maximum or a minimum? A minimum. So right here we have a little valley. Is that a true minimum or is it a relative minimum? It's a true minimum. So our minimum. And when we're asked to identify it, we're going to label it. We're going to identify it as a point. So our minimum is at 0, -4. Nope, -5. Looks like it's a little below. All right, I'm going to rewrite that 5 because it looks all crazy. Boop, there we go. 0, -5, because it looks like it's between the -4 and the -6. All right. Now let's do g of x. That's all we have to do on f of x. Let's do g of x. I have 2 places where it makes either a mountain or a valley. Got this one. And wow, I was bad at that when I wasn't looking at it. And this one. So my little pink point up here, this guy. Is this a maximum or minimum? This one. It's a maximum. Is it the very, very highest on the whole graph? Is it a true maximum or is it a relative maximum? It never, ever, ever goes higher? It's a relative maximum. So we have a relative, I'm just going to say relative max, because that's way too many dang m's to write. At the point, and we're going to label it -2, 8. We're putting our ordered pair, that xy pair. X then y, just as a reminder. How about our blue point? What's that one? This guy. a relative minimum. Or a relative min. And that is at the point 0, 4. Does this one have a minimum, like a true minimum? No, because this goes down forever. Same reason it doesn't have a true maximum is this one's going up forever. If there is an arrow pointing up, it will never have a true maximum. If there's an arrow pointing down, it will never have a true minimum. If it's got both, it's only got relatives, if that. Okay? It doesn't necessarily have to have any of these. It could have all of them, it could have none of them, and it can have anything in between. Questions on these two before we do the real wonky one? Okay. Real wonky one. Mm-hmm. Yep, we've got a true maximum. Where's our true maximum located? 12. Yeah, 12 and like 11 and a half-ish. Somewhere around there. So our true max is at 12. Maybe 11.5? Guessing. We're reading. That 11 looks weird. Try that again. There we go. The benefit of pencils or erasable, so we can fix it when it looks funky. All right. What else we got? Another, so a relative max. I'm just going to put rel max. Relative max. Where?
1610.
1610. This guy. It's another little baby peak. What else we got?
A relative minimum.
A relative minimum where?
14.9.
14.9. We got a little valley right here. So a relative min at 14.9. Anything else?
No.
A second relative minimum. Where?
4.
4. Yeah. So we have another relative minimum. Here. 4, 2. I'm going to call it 2. I know it's slightly below. It could be 1.8 or 1.75 or whatever. It's close enough. Yeah, so it's got a lot of information here. We have a lot of changes. We're going to talk through what this means by context because that's one of those things that will show up frequently. So what does it mean for our max to be at 12? What does it mean? It can't go higher than 12. It was the absolute most number of social media posts since midnight. At 12 hours since midnight, they posted 11,500,000. So 1.1 million. Social media posts. I guess we're talking about air tour. So then we had another little baby peak. We had this other relative. So we had this relative max. There was another peak at 16 hours. Something must have happened. There was a big drop after that 12 hours since. There was a drop there at 14. Maybe the concert was happening then. It'd be weird because it's like 3 in the afternoon. But whatever. Everyone's driving. So there was a drop here and then another little baby peak. And the very, very fewest posts happened at 4, according to this. We've got this continuing trend because the trend is going on. So we don't have a true minimum. But there was a big old drop since they started measuring right here. It went down, then it came whoosh, right up. So we had, everybody was at the concert, then we announced 1980's version. And everybody went crazy, then we went to sleep. Then we started posting again, and then it started to drop off. Yes, my friend. So the relative max versus the relative minimum, it just are the little changes. So if we were just looking at maximum and minimum, we wouldn't care about these guys at all. Because this is our lowest point on the picture. It's continuing on, so it is still a relative. It just means in this neighborhood, that guy's the lowest. In this neighborhood, he's the highest. I'm just looking at little pieces. So it's just talking about where there are peaks and valleys. Because if I just said we have this is our lowest and this is our highest, I wouldn't have any information about these guys. So we're just looking at for where it's changing directions. What's up, Giovanni?
So on the definition, is it where there are no nearby points that have a
Right.
wide value? What do you count as nearby? Like one?
So if you think of, if you think about it, neither of its neighbors have a higher Y value, or its neighbors. So as long as nothing next to it has a higher Y value, you found a little baby peak. That's just kind of like the mathy definition of it, is that nothing next to it has a higher Y value. Nothing next to it has a higher Y value. Same thing with our minimum. Nothing next to it has lower Y value. It's the bottom. You found a dip. Okay, good questions, guys. These are all really good questions. I love questions, by the way. There's no such thing as too many, too small, too weird. Questions are good. Yes, I am weird. I get it. I admit it. All right. So what we're going to do is we're going to have the rest of this time to work on Alex. I want you to go into Alex. There is a week 1 check. So to kind of see how we're doing, where we're going, how we're feeling. It will continue to give you questions until we get it right. If you get all the way through the week 1 check, you can work on your pathway. And then I'll hand out homework 3 next week because we've only talked about one tiny piece of it. So I'll hand out homework 3 on Monday. It's not super long. We are going to have a quiz next Friday. A week from today, we're having a quiz. Okay? I will get you a review. All that jazz, we be good. All right, but I want you to work on Alex, work on the week 1 check-in, and then you can work on your pathway. I am about 75% sure it's called the pathway. If you are unsure what to go or where to go or what to do, let me know. I'll help you through stuff, okay? On Alex, you go through Canvas to the McGraw-Hill link, and then you click on Alex. So Canvas, our course, left-hand side, McGraw-Hill, SSO, and then click on Alex, not the textbook.